Good afternoon, everyone. Welcome to the afternoon session. And in this session, we'll have two themes. The first theme will be software and system security. We have two talks. And then followed by that is the theme of incident response and governance. And for that theme, we have two talks. And the first talk is given by Mr. Omar Jakas. Omar is a first-year PhD student, and his talk is leveraging hardware-based solutions for robust cloud container security. Omar, are you ready?
Yes, thank you, Doctor. So good afternoon. Thank you guys for joining me today on my talk titled Leveraging Hardware-Based Solutions for Robust Cloud Container Security. As Dr. Naipang said, my name is Omar Jakas. I'm a PhD candidate in Systems and Software Security at the School of Information Technology and Electrical Engineering. So just before I start, this is a brief outline of the topic today, the introduction, understanding hardware-based cloud containers, and then looking at the current container security measures, and future perspectives and conclusion. So introduction, just a brief overview of the key concepts, which include cloud computing. So just a brief definition of cloud computing. Cloud computing is the ability to outsource IT services to outside vendors, and having these vendors leverage economies of scale to ensure reliability, cost saving, and scalability. And as you can see, cloud computing is an ever evolving domain and is projected to have a market cap of over 600 billion in 2023. And when we talk about cloud computing, one of the fundamental technology behind cloud computing is virtualization. And virtualization simply is the ability to go from monolithic software controlling the underlying hardware to multiple software sharing the underlying hardware. This technology is fundamental because it's the technology that allows cloud computing to leverage economies of scale, to have enhanced security, improve disaster recovery, scalability, and optimize resources use. So when we talk about cloud virtualization can be split into two types, and these are hypervisor-based virtualization, this type of virtualization is dictated by its name, which includes a hypervisor, and a hypervisor is the software that enables the sharing of the underlying hardware, and it's dictated by specific rules and specific rules such as performance, fidelity, and safety. And container-based virtualization is the other type of virtualization, which is creating isolated containers on single operating system or a single host. Imagine Docker and Kubernetes. So the advantages of hypervisor-based virtualization is that it's hardware-based. So basically, because of its properties, it has direct control over the underlying hardware. This means that it has enhanced security because it's directly controlling the hardware, and a smaller TCB than using container-based virtualization because it's not using an operating system as a trusted computing base. It's using the hypervisor, which is more single purpose. However, hypervisor-based virtualization means that you create isolated virtual machines on a single physical host. And creating multiple virtual machines means that you need to create a dedicated guest OS for each virtual machine. This has an impact on the deployment density, which results in an impact on performance of the entire system. On the other hand, container-based virtualization leverage one single host, which is the operating system, and it performs software-level virtualization. While this has impact on security because it's software-based, which means that the isolation threshold is lower, it it means that you have a much improved security and efficiency in terms of virtualization. So when we talk about virtualization security, also virtualization security can be split into two types. And these are hardware-based security solutions, which leverage physical devices designed to provide a secure environment or augment software security, or software-based security solution, which are rules and standards embedded within software to safeguard data and network security. And when it comes to hardware-based security solution, we can see that there's a lot of commonalities with the hypervisor-based virtualization, which because hardware-based security solution are more robust, because naturally hardware is harder to subvert than software, which makes it a more trustable source. So that means it can provide enhanced security. It's hardware-based. It has a smaller TCV than software, but it suffers from low performance. On the other hand, software-based security solutions are high performance, but are software-based and less secure. So as you can see here from this diagram, there's an inherent performance security trade-off when it comes to virtualization and virtualization security. So before we go into the different hardware-based container security measures, I just want to emphasize the intersection between the three major topics related to cloud computing, which is cloud computing itself, container-based virtualization, which is a type of virtualization, and hardware-based security solutions. So in pre-2000s, in the early cloud days, actually the cloud started as it traces its root in the DARPA project in 1960, where the goal was just having two users use the same host. And the earliest reference for software as a service was in the 1990s, where the goal was just to access software remotely. And then in the 2000, Amazon leveraged cloud computing in 2002 and AWS in 2006, and Google and IBM followed that. And then in the 2010s, cloud computing evolved from private and hybrid models into multi-cloud models, emphasizing security and developer-driven services. Going to container-based virtualization pre-2000s, container technology started with Unix change root system process isolation. And then in the 2000s, Google introduced Borg. And a lot of different technologies were introduced, such as C groups and Linux containers, which refined container technology. And then in the 2010s, Docker revolutionized containerized technologies, and then Kubernetes was introduced as an orchestration and a management layer on top of containerized environments. And finally, for hardware-based security solution, it started out with basic hardware security primitives such as random number generation. And then in the 2000, Trusted Computing Group introduced trusted platform modules in the TPM for enhancing the platform security. And then in the 2010, SGX became popular and became one of the leading solutions to having a trusted execution environment for critical data. And now in the 2020s, hardware security is becoming more and more important with the technologies such as IoT, cloud computing, and the emphasis on on encryption and secure boot. All of that culminates in post-2020 now, where we can see that Kubernetes is dominating environments such as the cloud, and security integrated into development and containers, promising lower cloud computing costs, and future perspective and emerging technologies such as confidential computing, data sovereignty, and government requirements. So with all of these three domains, we can see an intersection between them that offers vast potential for creating secure, efficient, scalable system that accelerate digital innovation while keeping resiliency high for computing environments. So with that said, this is the current landscape for these type of hardware-based container security technology. As you can see in this diagram, I have categorized or grouped those mechanisms into 4 different types, which are trusted domain, hardware virtualization support, trusted execution environments, and trusted platforms. And from these fundamental 4 types, there are the hardware technologies that evolved from them. And then there is the software that is built on top of them, which is called the runtime environment. And there's also library OS, which are dedicated unikernels for specific technology that ensure a trusted execution environment for them. And then you have application built on top of those hardware-based solution that either uses them to provide security or a software layer that provides security to other softwares. So with that said, going into each technology in more depth, we first start with trusted platforms, and trusted platforms are devices and systems equipped with hardware security modules, HSM. And the most famous HSM of trusted platforms is the TPM, which is the Trusted Platform Module, which provides facilities such as hardware root of trust, ensuring systems integrity and confidentiality. The feature of them are the feature that can be used for the cloud. How TPM is used in the cloud is for functionality such as security from the ground up, identity and access management, enhanced data protection, and integrity verification and remote attestation. And these functionalities can be used for the 2 different types of virtualization. And even for cloud container, as these features can be extended to containers or can be used in a different way for container environment. The strength of these technologies is that they provide a granular level of security for the entire platform, but they have their own weaknesses such as side channel attacks, some hardware restriction in terms of the functionality that they can provide, which means you have limited security features and you have some firmware dependencies for it to work. And also firmware, even though the firmware TCB is small, it can also have vulnerabilities. The second type is hardware virtualization support. So hardware virtualization support, in essence, is a hardware-based solution to provide virtualization. However, it can be used to provide security through isolation or by repurposing the virtualization primitives to provide extra security features. So in essence, it's just using a hardware CPU extension to facilitate or accelerate virtualization. But this acceleration in virtualization provides a hardware-based level of isolation and enhances the performance. And virtually all of cloud providers use this type of hardware virtualization support to accelerate virtualization. And containers can be deployed on these, even though it's a VM hypervisor-based VM isolation. Containers can leverage these type of technology to deploy containers inside of those isolated VMs, and or can repurpose those virtualization primitives to have a dedicated security solution. The strength is that it's widespread in terms of availability. All cloud vendors use that technology in one way or another for security or for enhancing performance. It's widely supported, scalable, and easy to use, especially in containers, because you just employ a lift and shift strategy just to deploy containers inside of isolated VMs. There's some weaknesses in the repurposing, especially when it comes to containers, and it has limitations in terms of the security that it can provide. So from hardware virtualization support, we transition into something called trusted domains, which is basically using the same virtualization primitives, but encrypting the entire VM's runtime environment. And these are demonstrated by emerging technology, very recent emerging technologies such as the Intel trusted domain extensions and AMD secure encrypted virtualization. And basically, think about these type of trusted domains as an encrypted VM running in real time. This type of technology ensures a lot of security guarantees. However, it has a lot of limitations in terms of securing the application from the underlying host, securing the application from its own vulnerabilities or vulnerabilities found from other applications inside the VM. And it suffers from a big overhead in terms of runtime memory encryption. And it's also vulnerable to side channel attacks. And finally, trusted execution environments. And trusted execution environments, I think, is the most famous in terms of hardware-based container security technology, demonstrated by the relevance of SGX in recent years, and also ARM Trust Zone. And basically, the features are secure processing, isolation, sealing, and remote attestation, which is basically trying to provide a small trusted execution environment for application to run safely. The good thing about SGX and why it's very popular is that it provides fine-grained security for application or services or containers, because you can deploy a container inside an SGX enclave. And with the correct implementation, you can have it secure from the underlying hypervisor and guest OS, and have a very high level of control over all the input and output that it allows. So with that said, hardware-based container security solutions are motivated by 5 key trends emerging, which is the increased adoption of zero trust architecture. So zero trust architecture means that every user and device is considered potentially compromised. And we're seeing more and more of those types of architecture emerging. And also a greater emphasis on privacy and data sovereignty, like regulations such as GDPR and such regulations ensure that organizations will continue to invest in cloud security tools and to ensure compliance and data privacy. And the use of confidential computing, which is one of the biggest emerging cloud security technologies, which is trying to make data in use or data in process completely encrypted and completely verified. And serverless architecture, while serverless architecture are not growing as much as before, they still have unique challenges that can be security challenges that can be solved with technologies such as SGX, where you can put functions inside of SGX and provide some runtime protection for them. And the expanded use of DevSecOps practices and having security integrated into every stages of software development, rather than being just an overthought and being done at the end. So with that said, navigating the digital landscape, the intersection of cloud computing, containerization, and hardware security has a high potential for creating secure, efficient, and scalable system. Current security measures such as have strength and weaknesses, and there is no approach that can provide a comprehensive solution. And future trends in cloud security include adoption of zero trust architecture, data sovereignty, confidential computing, serverless architecture, and DevSecOps practices. And fortifying container security requires continuous adaptation, innovation, and vigilance. And our digital future robustness is dependent on how securely we construct our present. And this is all for me. Thank you guys for listening. I'll open the floor for any questions.
Thank you, Omar. Any questions?
Thanks, Omar. Ivano here. Good to see you. Just a quick question on the data sovereignty part. I was interested by the fact that you kind of highlighted future perspectives in terms of, on the one hand, focus on data sovereignty, on the other hand, confidential computing, which is probably something that really is up to very different type of actors. I'm seeing data sovereignty, obviously a focus on governments, confidential computing, possibly more at the organizational and the individual level. How do you see the two interact moving forward? Thanks.
That's a very, very great question, Ivano, because I think confidential computing will be the driving force of cloud adoption, of solving data sovereignty in the challenge of cloud adoption, because confidential computing provides the necessary tools for data sovereignty in cloud environment. Even if you have your data with a remote vendor, you can still provide data sovereignty and ensure data protection using technologies such as cloud computing, because cloud computing offers security primitives such as such as runtime memory encryption, meaning that while your data is being processed remotely, you can ensure that it's being encrypted and integrity verified, and remote attested all the time, and isolated from everything else. So in short, confidential computing will significantly increase the security of the cloud, which will make cloud adoption much more easier for companies that want to ensure data privacy and compliance.
Any other questions? If not, let's thank Omar again.
Thank you.
Our next speaker is Mr. Joshua Squasbrook, and he's going to talk about his recent research on Tiny Range. Tiny runs everywhere, Linux networks for cybersecurity education. Are you ready?
Yes. Excellent. Thank you, Naipong. Today, I am going to give a bit of a talk about Tiny Range. I hope a lot of you here have had the opportunity to come and see it in action over in our tours that we've been giving through the Cyber Wing over in GP South. So this talk is going to focus a bit more on the fundamental internals of why Tiny Range works as well as it does. So firstly, a little bit about me. My name is Joshua Squasbrook. I'm a research officer at the University of Queensland and a PhD student here as well. My main interests are in the area of operating systems, virtualization, and embedded hardware. As far as my background, I have organized/co-organized 10 CTFs of various sizes and 4 attack defense challenges on various different types of infrastructure. As I was working with that, I was frustrated with the state of cyber ranges. As I was frustrated with the state of cyber ranges that existed back then. They require a lot of hardware. They require a lot of maintenance to get working. They're very difficult to actually engineer challenges on, which, as a lot of very technical people have unfortunately learned over time, people don't really care when you make a cool piece of technology. maybe researchers do, but what people really want is they want good quality exercises, and they want to be able to do that in an efficient manner. So what is Tiny Range? Tiny Range is, the goal of Tiny Range is to reduce the cost, complexity, and time to set up cybersecurity lab environments to zero. I want to make it so that if you find some kind of cool cybersecurity exercise online that you want to start playing with, there's no barrier of entry to do that. You download a small scenario onto your computer and it works. Teachers in a classroom, they want to teach the students about cybersecurity. All they have to do is find a good cybersecurity curriculum that's hopefully made available through the University of Queensland, and start teaching that in their classes, and we pretty much provide the rest. This all sounds like a very interesting goal, but I'm going to start off being frank with you that Tiny Range does have some limitations, just because I want to set proper expectations as we're going forward. So firstly, in terms of limitations, right now there is no Windows guest support in what Tiny Range does. Tiny Range, for reference, Tiny Range starts up Linux-based virtualized cyber ranges, and it's focused on doing Linux guests at this point. It's designed for a single user sitting in front of a computer. So if you want to host a cyber range for a group of 100 people, you want those 100 people running Tiny Range on their computers, rather than hosting it centrally on some cloud server somewhere. Tiny Range is designed for the person's computer that they're sitting in front of. Tiny Range is also not the option that you want to use if you want the highest possible VM performance. It's lower performance than VMs booted in something like VMware and Hyper-V. In some instances, it's still very competitive, like for CPU-bound workloads. With hardware acceleration, Tiny Range can be, in some instances, faster than the computer that you're running Tiny Range on. How that's possible is Windows and Mac OS are not particularly good operating systems when it comes to their process scheduling. The VMs in Tiny Range are not connected to the internet. This turns out to be both a blessing and a curse, but the upsides definitely outweigh the downsides. The VMs being isolated makes it easier to bring Tiny Range across different systems, but them not being connected to the internet makes the initial process of software installation a bit more difficult. And finally, Tiny Range is not at this point really designed to interface with hardware. So if you want to run a VM that talks to a STM32 development board, then Tiny Range may not necessarily be your best option. But all of that being said, what does it actually do? It's a cybersecurity lab in a box. Tiny means it uses minimal resources. Everywhere means it runs everywhere. When I say everywhere, I mean, if you have a computer, if it runs an operating system, if your computer meets the minimum requirements to run that operating system, then I'm pretty sure Tiny Range will run on it. If you have a Windows laptop from 5 years ago that has like 8 gigabytes of RAM, maybe a dual core or quad core CPU, that's perfectly fine. You can run some pretty complicated challenges on that. And because of this, it scales well across different systems. You can run Tiny Range on I should have bought more fancy things to show off with me, but Tiny Range will run on everything from a tiny little Raspberry Pi, which we have over in GP South, to really big giant servers. And if you have a big server, you can run hundreds and hundreds of virtual machines on it, because the core of Tiny Range will run in as little as 300 megabytes of RAM. If you have a system, if that system can run software, and if you have 300 megabytes of RAM free, you have enough space to have a Linux VM and start running software and other applications inside of that. As far as platform support is concerned, for now, it runs on Windows, Mac OS, and Linux, regardless of the system security configuration. But these slides were actually based on a talk that I gave over in the city a few months back. Since then, Tiny Range now provisionally runs on Android. So if you have an Android-based phone, even if it's not rooted, Tiny Range will run on it. It won't be particularly fast, though. It does this without admin privileges, no mandatory installation. When I gave a demonstration of Tiny Range over in GP South, to set that up, all I did was go around a bunch of computers and copied some software over from a USB flash drive. That was about 100 or 200 megabytes of software. That makes up tiny range in the scenarios that we were running, so incredibly minimal. So long as you can run an executable, you can run tiny range. I have to say that because I assume at least some crazy organizations here are doing full application whitelisting. And if your organization is doing application whitelisting, then unless you whitelist tiny range, it won't run. But to the people who are doing that, that should be obvious enough already. One of the goals longer term is more platform support. I want to run mobile. I want to run on web browsers. I want to run on basically any kind of hardware people have. And that mobile and web browsers thing is a really nice thing. If your organization has application whitelisting and I can't run an actual executable on your machine, then you're probably going to let me run something in a web page instead. Makes it more accessible to people. One of the interesting things about tiny range that we're doing about it from a university standpoint is we're working to make it open source. As like I said at the start, nobody really cares about your technical accomplishments. They care about what you actually do with them. And one of the big things to learn in the cybersecurity industry is if you make a cool tool like tiny range that you can run all kinds of educational material on, then you can charge organizations a little bit of money for access to that tool. But organizations are not going to pay a lot for that, and that's not going to be a good reoccurring revenue stream, whether you're a university or whether you're a third-party partner. Instead, what organizations will keep coming back and paying you for is things like scenarios, other designs, actual curriculum that you build on top of tiny range. So it makes sense that the actual core platform of tiny range is as available to people as possible. It will be under a permissive license, GPL-like. The exact details of this are still being worked out, but in terms of how it does it, the core of tiny range accomplishes very low requirement virtual machines using 4 key strategies: user mode networking, micro VMs, a custom boot process, and a monolithic core. The user mode networking is how tiny range runs without admin privileges. You can run surprisingly complicated VMs without administrative privileges, but as soon as you want those VMs to start talking to other computers, other systems, that's where you run into problems. So tiny range uses a derivative of Google's gVisor network stack that they developed to do its networking entirely in user space. It implements its own routing support. So from a host perspective, tiny range is just a piece of software that opens, reads, writes files that is talking to other pieces of software that opens files, reads, writes files over UDP sockets. That's one of the reasons why tiny range is able to run on such a wide range of systems, because rather than going for a really specialized kernel acceleration for the networking or tap and ton devices, all kinds of options like that, the whole key of it is just keeping it simple. And that's also why the VMs don't have unrestricted internet access, because a regular user mode process can open its arbitrary sockets and it can send arbitrary data on those sockets, but it can't do things like listen on protected port numbers. It can't do things like listen on multiple IP addresses, things like that. So there are still some limitations for internet access. The next one is micro VMs. Tiny range does run using virtual machines, but these virtual machines have minimal hardware and boot the Linux kernel directly. They don't have a CD-ROM drive. They have storage, but the storage is just a very basic file. And some custom solutions for doing micro VMs, Firecracker, etc. But most of those require KVM. Briefly, KVM stands for kernel virtual machine. And it's part of the Linux kernel that allows it to do hardware acceleration for VMs. That drastically increases the speed that VMs are able to run, but you need administrative privileges once to give regular users access to that. Same thing on Windows. Apple is surprisingly forward in that area. You don't need any additional privileges to run virtual machines. Any user on an Apple machine is already able to. And depending on your Linux distribution, you're oftentimes already able to, so long as you're in the right user group. Like a default Ubuntu installation, you're not going to run into any issues. other operating systems, you may need to be in the KVM group. So in the past, I used Firecracker, which was used, and the core concept of micro VMs has been used by Amazon for their Lambda service, which is how they're able to provide such cheap function execution because they can run such small virtual machines. All in all, it leads to very low virtual machine overhead. Another thing is how the VMs in Tiny Range actually boot. VMs network boot from small images into a RAM disk. So if you talk about a standard virtual machine, then that standard virtual machine will boot a lot like a regular computer does. It'll probably boot from a virtual CD drive to a virtual, and then format a virtual hard drive, install an operating system on it, and reboot into that operating system. That's not how Tiny Range works. Tiny Range effectively network boots the system straight into a RAM file system. The actual rootfs, the part that you run software on top of, tends to come from Alpine Linux or a Docker image. It's also still running after the actual VM is booted up, and that allows you to do things like, say, if I make an HTTP request to the host can then go back and say, I'm going to push this file onto this VM. You effectively get some sort of free system administration of the VMs while they're booted up in Tiny Range. Finally, there is the monolithic core. Like I said at the start, Tiny Range is able to have an entire virtual machine with its entire capabilities sitting in under 300 megabytes of RAM. The way that it does this is it compacts all of the services that the virtual machine needs to run into a single executable, effectively. So the VM just talks over the network to this executable. This executable provides DNS, DHCP, HTTP proxies, and everything else. And part of how Tiny Range has been so efficient, these services all integrate with one another. So giving an example, when the DHCP server detects a DHCP request from a VM, it will assign an IP address to the VM, but it will also send a notification to the management that that VM has come online, which triggers a callback for the VM to start its next stage of initialization. Or for instance, DNS looks up regular DNS records, but it also looks up metadata from VMs directly. And all of this is fun technology, but like I've said before, technology is great and all, but the actual use case is what's important. Who is this for? It's for high schools and it's for high school students. I want to make cyber range that everybody can have on their computer, that you can go out to a school, run advanced cybersecurity exercises, effectively anything that'll run in a Linux VM, and make that easy for people to do. If you're a business who has some advanced piece of software that you want to start working with students on, you can make that software available in a Tiny Range VM, and hopefully eventually that school will have Tiny Range installed there already. You won't need any other software installation. You won't need any other network ports open. You won't need anything else. You'll just be able to run your software, run your education environments. And the fact that Tiny Range is so small, that turns out to be really good for teachers. Students and teachers are highly cost sensitive. I remember being a student many years ago. I learned about IT administration because I couldn't afford a World of Warcraft subscription. I set up a WoW private server, which meant setting up a fleet of software applications, meant setting up a Microsoft SQL database server, all of that, just so I could play World of Warcraft. But teachers also want highly packaged functional solutions. And finally, it's something, we've tested Tiny Range out in a number of schools, and something that's blown me away is students really have a desire for this to learn. And the kinds of things that you can teach them is not something that we expected. You can give students exercises including Linux terminal, even compiling C programs for more advanced students. We haven't yet figured out what's too advanced for high school students to do, at least with the proper background and training. What are the next steps? Better VM definitions. I can make my own definitions for virtual machines within Tiny Range reasonably fast and easily, but it requires knowing 5 different programming languages right now. That's not something that's going to be accessible to people. So I want to make this accessible to people of all skill levels. I want to make Tiny Range more extensible, because if you're an organization and you have a bit of software that needs some kind of specialized network service behind the scenes, being able to integrate that into Tiny Range may end up being the best option for running it, especially if you want to be able to run it in a resource-constrained environment like a school. And networked environments. If I can take a laptop and any laptop you have here and spin up a bunch of virtual machines on it, that's great. But in a class, we want to have students collaborating with each other. How can we turn a classroom of student machines into a cluster? That's still an open question as to how exactly we're going to do that. But that's something I've been working on. And finally, as a list of acknowledgements, I'd like to acknowledge Dr. Marie Bowden, who has been helping out with external engagement with schools for the project. I'd like to acknowledge Professor Ryan Coe as my mentor and the brilliant cybersecurity strategist that he is. And I'd also like to acknowledge UniQuest and Research Legal for their assistance with working with third parties and helping us on the licensing front, and many others that I'm currently forgetting. And yes, thank you for listening.
Thank you. Any questions?
I'm going to preface this by saying I'm a non-technical person and I may have missed the mark on some of those acronyms, so apologies for that. Is there a possibility to take Tiny Labs and potentially allow what I'm thinking of for small and medium enterprises and businesses who often have one IT person who's having to do a lot of application development? Is there the opportunity to potentially take the same type of learnings and give it to businesses and potentially make revenue that way?
Thanks. That's a really great question. It's something that I've considered, and I'm in mixed feelings about it. In one point, I'm aware that people will take the path of least resistance when they're given a challenge, when they're given a job to do. And if Tiny Range is the path of least resistance, then we may see web servers and other things being hosted on Tiny Range. But it's not designed for that, and I want to actively encourage people not to do that. Where I'd rather sit is I'd rather provide educational content that shows people how to set these things up themselves, but better, how to set things up properly, rather than trying to have small and medium enterprises deploy production services. But I do think there is still capability for another person to take the core technology of Tiny Range and use it to make something that can host services for small and medium businesses in a way that's more practical, particularly looking at like the scenario definition format that Tiny Range has used or some of the virtualization learnings. I probably wouldn't use the networking though for actual production services.
Any other questions? I have one. Yeah, this Tiny Range can be very practically useful. I just want to, since you mentioned that you're going to use it for education, just wondering whether you have already embedded some of this security exercises into Tiny Range.
Mm-hmm. Yep, we've had a number of security exercises. We've had a number of security exercises that we've been running with school students already, built on top of Tiny Range, ranging from very simple CTF style challenges to ones where I had one that was very successful with students where we gave them the C code to an implementation of 2048 and said, here's a game that you can spend the rest of the class playing, but you have to compile it yourself. That turned out to work very well. And I think that there's opportunity to engage students around doing things like Minecraft servers as well.
Do you think that's possible to be improved to do a red and blue team game?
Definitely. I have spent a fair amount of time looking at how Tiny Range could be used at a larger scale. And there was a project for us to try and do that a while back. Tiny Range didn't quite end up being ready for that kind of use case at that stage, but I have tested that at a smaller scale and it works very well for it.
Thank you.
Thank you.
Yep. Let's thank Joshua again. Our next talk will be given by Alina Singh, and she's going to, her talk will be conceptualizing cyber resilience. How can we encourage this adoption?
So my presentation is on the contextual nature of cyber resilience and also the factors that could be potentially leveraged to encourage its adoption. So currently organizations face immense pressure to actually improve and develop their cybersecurity and resilience. And this is also true considering that cybercrime costs are expected to increase. So this means it's more than likely that organizations will actually face cyber incidents that might make it harder for them to continue operating. However, the question is why is this happening? There's increasing guidance provided to organizations about cybersecurity and resilience, and they are already facing increasing pressure. So in this research, the suggestion to that problem is that it's because a lot of the guidance tends to be presented as one size fits all. And also there's an assumption that all organizations are motivated by the same things. So in this case, it suggested that if guidance was presented in a more contextualized format and there was greater investigation into the potential factors that encourage adoption, this might help to present cybersecurity and resilience in a way that could improve its adoption by organizations. So the structure of this presentation is as follows. So I'll present the research questions that help to address this idea of a contextual cyber resilience, followed by the research method, the findings and analysis, and then the contributions. So to begin with, this research is focusing on cyber resilience. So cyber resilience builds on cybersecurity. And the choice of this focus is largely because cyber resilience by its nature actually aligns very well with organizations already, because they already tend to think of the idea of resilience when it comes to doing their disaster management. In addition, cyber resilience encourages a focus on cyber incidents, and this can be more realistic because it accepts that organizations will be attacked, so they need to be focused on the long term. In addition, as in the name for resilience, it focuses on bouncing back in a holistic approach, encouraging technical and non-technical measures. The origins of cyber resilience come from three main research areas: resilience, which is in the name, disaster management, and cybersecurity. So each of the three areas contribute a unique facet to cyber resilience, and they're useful in the sense of showing that cyber resilience needs to be something about recovery and about focusing on incidents, and also that the context or the type of measures that should be used will be based on what's done in cybersecurity or cyber practices. However, despite the theoretical strength of cyber resilience, its adoption tends to lag. And so this is because a lot of guidance tends to be presented very generally. So it's more like suggestions that organizations should be doing. In addition, it tends to focus on specific sectors or industries such as financial markets, infrastructure, or defense. In addition, a lot of guidance tends to say all organizations should be doing this, or potentially they might implicitly state, for example, that our small organizations might find it harder to do something, but they won't actually go further and say it's because they have different needs or resources. So then this creates uncertainty for organizations, because as they see the guidance, they'll either go, yes, I can implement this, or they'll start to go, no, and they'll stop caring about cybersecurity or resilience. In addition, it means that it's also very hard for organizations to measure and assess it. So if they do implement cyber resilience, they can then find it much more difficult to decide if they're actually improving it as time goes by, or if they're simply just remaining at a status quo. So considering these issues, this then led to the three research questions to address both the measurement and implementation of cyber resilience, and then exploring the contextual nature of it. So in the first one, I look into the concept of cyber resilience and how it can be measured. And then from there, I focus on the contextual environment, which will comprise of institutional pressures and internal characteristics such as contingency factors. And then finally, I will look at how cyber resilience is associated to cyber incidents. And this is important because at its core, cyber resilience is a focus on cyber incidents. So it needs to be seen that cyber resilience can actually help or perhaps be associated with improved cyber incident outcomes. So considering the limited research and data that's currently available, the first part was to then do an exploratory study. And this was needed to actually demonstrate that this idea of contextual cyber resilience was possible. So this was done using public data, which was used because it can help to show the minimum that an organization has implemented, because the public data will necessarily show what the organization is willing to disclose, and it'll be what they've actually more likely implemented, because otherwise, if they've lied about what they've implemented, this could lead to lawsuits or other litigations. So data was collected from 1,145 cyber incidents and then analyzed to see if there were any relationships based on this model. So this model was developed inductively based on existing frameworks and guidelines and literature, and also what was observable in public data. So you can see that there's the exposure factors, which are the contingent factors or internal characteristics or external, then cyber resilience, and then looking at how cyber resilience is associated with outcomes. So based on the model, and the analysis conducted, it showed that sector was important and that there's also an association between cyber resilience and litigation and penalties. It was also demonstrated that there were potential relevance in the model, but that how it had been constructed and the fact that it was quite naively constructed based on public data that needed to be reviewed and improved. So then this led to the second part of the methodology, which was a more thorough investigation into the model following best practice, particularly McKinsey, Podsakoff and their work around construct development. So in this, the first part was defining the dimensions of cyber resilience, institutional pressures, contingency factors, and outcomes, and then taking that to practitioners to then review and refine. From there, this was then taken to a survey to then collect data to then test the model with follow-up interviews conducted to then evaluate the insights. So a mixed method approach was needed because it's important with cyber resilience research that it's both relevant for academics, but also relevant for practitioners. So in terms of the constructs for cyber resilience, it was defined as a 7-dimensional construct comprising of prevention, detection, education, response, recovery, accountability, and strategy and planning. So this was derived from existing frameworks and guidelines such as NIST, Cybersecurity Framework, and MITRE's work, ISO 27K, and then also existing literature. So generally, you can see that there's an overlap with cybersecurity and its current conceptualization. The main difference or the main way that cyber resilience builds on cybersecurity is that it also recognizes equally the importance of education, accountability, and strategy and planning. So from there, the next construct that was developed was for institutional pressures. So institutional pressures is derived from DiMaggio and Powell's work, and it recognizes that organizations might be influenced by what's happening outside. So for example, in DiMaggio and Powell's work, they mentioned the idea of coercive, normative, and mimetic pressures. So coercive pressures are any forces or influences that that make an organization feel that they have to do something. So a typical example is legislation. And whereas normative pressures refer to any standards or norms that an organization feels they need to conform to. So these are typically cybersecurity standards. And the mimetic pressures represent when organizations feel they need to copy or mimic behaviors or practices. So in this research, it was identified that mimetic and normative pressures would be combined together because there's an indication that there's a small number of institutional actors that are powerful, so their actions may be interpreted in multiple ways. So for instance, cyber resilience frameworks are both seen as norms, so they encourage an organization to act in a certain way, but they also provide practices that an organization should be implementing, so they have a mimetic influence. From there, 4 contingency factors were identified, and these are considered internal to the organization, and they were top leadership support, sector, size, and digital intensity. So in terms of identifying these measures, they were identified indirectly through or implicitly through the literature and what industry had stated, in that recognizing, for example, that particular sectors have different expectations. So for example, the health sector will usually have greater legislation or regulations put upon them. They might have greater expectations around like privacy and confidentiality compared to other sectors. And then the final final construct developed was outcomes. And so they were organizational, reputation, and financial. So these were again developed based on cybersecurity and resilience literature. And these are essentially the outcomes from any cyber incidents. So typically there'll be outcomes on the organization relating to like the ability to operate. Perhaps maybe they can't have their servers running because of the cyber incident. We also have reputation outcomes such as how customers are perceiving them. And then financial outcomes includes any costs. So after developing the constructs, the next step was then to take those constructs and then get them refined through a process of doing focus groups and then with a survey and then follow-up interviews. So the focus group was used to mainly assess the content validity and to check that the development of the constructs was relevant to what practitioners are actually seeing and observing. From there, this was then taken to the survey, which comprised of 110 participants who were cybersecurity practitioners involved in or responsible for the organization's cybersecurity. And then finally, the findings from the survey were then analyzed using PLSM or partially skewed structural equation modeling, and then taken to an interview set to then further analyze and refine the findings. These are the demographics for each of the empirical studies. So in terms of the findings, we'll start with first the cyber resilience, and then I'll go to institutional pledges and contingent factors, followed by outcomes. So with cyber resilience, it was generally found that the construct was valid, and it was also indicated that the most important dimension was strategy and planning. So higher cyber resilience was observed when there was higher strategy and planning. In addition, education was also important. For accountability, it was perceived as being important only when combined with other dimensions. So what that means is that accountability, which is leadership, is more important when it has something to lead. So if there's not other dimensions there, it can't really lead, which is reasonable. So it needs other dimensions to be important. From there, I looked at how the institutional pressures and contingent factors related to cyber resilience. So surprisingly, only mimetic and normative pressures and top leadership support were statistically significant, had statistically significant associations with cyber resilience. This means that coercive pressures such as cybersecurity or cyber resilience regulations were less important, same with size, digital intensity, as well as sector. Further analysis actually showed that, for example, government publications, so for example, the Essential 8 here in Australia, they were important for cyber resilience. In addition, standards such as NIST or perhaps MITRE's Cyber Resilience Engineering Framework were also important. What was interesting is that the knowledge of employees, so cybersecurity staff, they had the most importance, but they were also not observed frequently. And that means, based on this analysis, that if organizations put more effort towards the knowledge of their employees around cybersecurity or resilience, this could potentially see greater gains for their overall cyber resilience. In terms of outcomes, it was observed that, firstly, because of the small number of organizations that were attacked that were included in the sample, it was observed that some dimensions were higher in non-attacked organizations. So in particular, prevention, education, accountability, strategy and planning, and cyber resilience was higher in non-attacked organizations. And this may be due to the fact that these dimensions are considered more able to be dynamic, because you can easily change your strategy compared to perhaps implementing a new detection approach. It may be much harder than changing your education or how you're holding your staff accountable. In addition, it was demonstrated that organizations that were attacked generally had higher education with lower severity of operational downtime. So that essentially indicates that if the employees know what to do when they see a cyber incident, this might help the organization recover faster from the cyber incident. So considering the analysis, this was then taken to follow-up interviews to then further refine the findings and also link it to the broader environment. So in the table I have on the left, the findings, and then on the right, I have the follow-up interview discussions and implications. So beginning at the top, for cyber resilience, it was shown that it could be defined with the 7 dimensions, but the dimensions had varying importance. And this was agreed on by the interviewers, and that, some aspects of cyber resilience it's a process-based concept, so some dimensions will be more important. For example, strategy and planning contribute to the process of cyber resilience. So if you improve the strategy and planning dimension, this will help improve your process. In addition, it was reasonable for a lot of the participants that coercive pressures may be less relevant, and that's largely because a lot of guidelines or a lot of legislation is not currently there for cyber resilience. It's generally voluntary, so organizations choose to adopt it. In addition, a lot of the guidance or legislation tends to be more, you should be doing something, not if you don't do this, there's an issue. So for example, the increased frequency of like legislation such as GDPR may change this in the future. But because a lot of legislation is more suggestion-based, it wasn't seen as being such an important pressure. In addition, education and top leadership support as being important was accepted by the interviewees because this reflects the cultural shift in organizations. So because cyber resilience is voluntary, it means that the organization itself needs to choose to adopt it. And that means that they need staff who actually know about cyber resilience, are familiar with it, to choose to adopt it and choose to actually continue to support it as it's being developed. In terms of size, digital intensity, and sector, they were not found to be important. And this was considered interesting by some of the participants, but further analysis or discussion showed that this was due to the spectrum of organizations. So for instance, you could have a small organization that has no one working on cybersecurity or resilience, and so they're unlikely to have very high maturity. But at the same point, you may have another small organization that actually has someone who's working on it, or they've outsourced it to the point that they've actually had very high cybersecurity or resilience maturity. And that spectrum of organizations that could be observed lead to potentially these three factors not being considered important. Finally, it was agreed that potentially the lack of observable results relating to cyber resilience and cyber incident outcomes may be due to the fact that it's difficult for organizations to measure outcomes, so they might not actually know what's happening. In addition, it may also be that a lot of organizations haven't necessarily developed their cyber resilience to a dynamic stage. So that means that even though they've implemented higher cyber resilience or implemented cyber resilience, they haven't got it to the point where it's going to be able to respond to cyber incidents. Okay. And so then just concluding, so based on the findings and the analysis, this then led to the three research questions being addressed in such a way, in that firstly, I was able to clarify the meaning of cyber resilience, in that it is a technical concept, but it's strategy and people-led. And it encourages a focus on response and recovery, but in a way that should actually allow the organization to be dynamically evolving their cyber resilience as incidents change. In addition, it was demonstrated that cyber resilience doesn't exist in isolation, and that currently their environment or their broader contextual environment comprises predominantly of mimetic and normative pressures and top leadership support. However, this may change as new legislation or new guidance comes in. And finally, there was evidence suggesting that though cyber resilience may not be associated with incidents occurrence, sometimes the more dynamic dimensions of cyber resilience might be associated with incident occurrence. Again, though that's limited by the small sample of data for organizations that suffered an incident. So that concludes my presentation. These are the references. Any questions?
Thank you. Any questions to Elena?
I have one question about dimensions you mentioned. I think some of the dimensions are more technical, some other are more strategy level. But in some textbook, let's say that the strategy can be made and then policy can be generated, and then rules and implementation. So from my point of view, that prevention, detection, recovery, those are more technical terms, but the strategy is more policy level and so on. How that dimension can be equivalent in your study?
They can be, so thank you for your question. So they can be equivalent in that if you think of all, like in a single organization, they might not be equivalent, but in general, all organizations, they could be, because for example, you might have an organization that does not need as much detection because they may not necessarily be using, may not be connected to the network. They might only be using just their email or bank. And so in that instance, detection would be less important, whereas some organizations, they may only be caring about their prevention side. And so in that sense, if this makes sense, it's that on a general level, they're equal, but that in an individual organization, some dimensions could be more important than others, depending on their context. Does that make sense?
Thank you for your presentation. I was just wondering if your research revealed a way for organizations to quantitatively measure cyber resilience, as in assign a score to the cyber resilience of the company at that point?
So there are like individual items for each of the dimensions, and so they could score themselves on that. So I guess that would be, well, I guess, so it doesn't show it here because, wait, no. Yeah. So for example, it's on one of the slides. On example, there's actually a list of items, so they could score themselves on each of the items. So that would need to be further refined with additional research and like additional data collection to ensure that it's relevant to all organizations.
All right, thank you.
Any more questions? If not, let's thank Alina again. Thank you. So this is our final talk of this section. We have two speakers. Mr. Chen Miao, who is a first year PhD, and Mr. Hei-Ming Ho, he's at his final year of PhD. And this talk is going to be using situational crime prevention to prevent cyber crimes. The stage all yours.
Okay, I'm gonna start it. So hello everyone, welcome to the presentation. Today I'm gonna stay with Hei-Ming to talk about a different perspective of cybercrime prevention, which is about the criminology aspect, and discuss how to use situational crime prevention, which is a criminological practice to prevent cybercrimes. Firstly, I'm gonna give an introduction on cybercrimes, cybersecurity and criminology and their present state. So actually, the word cyber is originated from the Greek word steersman and first used in 1948 by Norbert in cybernetics, and then popularized in 1984 by William through cyberspace in novel neuromancer. As you can see here, the cyberspace is not a strong link to the crimes. This is because before 1960s, cyberspace is not created, or the concept of cybercrime is still unclear because limited of computer resources and technology resources. So some people believe that cybercrime is equivalent to computer crimes. So for example, the earliest documented computer crime was occurred in 1958, which involved in the alteration of bank records. And this type of computer crimes are direct to computer centers and did not much relevant to our daily life. And then after 1990s, with the increasing installation of PC and the commercial use of the internet, so internet become widely available. And the concept of cybercrimes comes to people's mind. However, such development of technology also brings criminal opportunities to the cyberspace, and which grow cybercrime in scale and complexity. And then in year 2006, Gordon Ford defined cybercrime as the use of a computer, network, or hardware device to assist or commit a crime. And then in 2013, Mike Groh and Dowling further explored the concept of cybercrime. They classified two types of cybercrimes, which are cyber-enabled crimes and cyber-dependent crimes. So what is a cyber-enabled crime? So cyber-enabled crime is traditional crime or the physical crime, which can occur in the offline world and can also be facilitated by the ICT technology. So for example, this type of crimes are cyber fraud and cyber abuse. On the other hand, cyber-dependent crime are direct harmful to the computer infrastructure. For example, the illicit intrusion to computer network by hacking and the disruption or downgrading of computer functionality and the network space by virus and DDoS attacks. So with time, we present cyber crimes are growing, bring monetary losses to the world now. So we now understand what is cyber crimes. So cyber crimes are criminal activities conducted using or through computer infrastructures. And we know cybersecurity protects information and computing infrastructures in terms of confidentiality, integrity, and availability to against malicious cyber attacks. Then we can conclude cybersecurity practice can prevent cyber crimes. But here I want to ask a question. Is us understanding cybersecurity enough for prevent cyber crimes? So let's consider a type of cybercrime, which is a cyber-enabled crime. So for example, an authorized employee may be a motivated offender who wanna commit internal data breach with his by utilizing his privileges in the organization. So under such situation, an access control system may be ineffective to prevent an internal data breach. So we want to say, although cybersecurity researchers and cyber criminology researchers are both concerned about cyber harms and their solution, cybersecurity protection measures may not always prevent cybercrime successfully. So therefore, there is a need to this is because the cybersecurity researchers mainly contributes to the computer science discipline and engineering field. They focus on secure hardware and software to prevent cyber-dependent crimes such as DDoS attacks. Conversely, cyber criminologists focus on the social science discipline to prevent cyber-enabled crimes such as cyber abuse and the misconduct behavior of employees. So therefore, there is a need to conduct multidisciplinary research such as applying criminology theory to understand cybercrime holistically and better understand why and how to prevent cybercrime from other disciplines. So this is also why and where we want to apply situational crime prevention, which is a criminological practice to lead the prevention program of cybercrime. And the next part, we'll talk about our paper about how to use ICP to prevent cybercrimes by my colleague Himi.
Thank you, Chemiao. So now I'll move on to the second section, where we discuss a little bit of how we can use situational crime prevention, or SCP for short, to prevent cybercrimes. Due to time limitation, I will just only cover briefly the overview, some research directions and the benefits. Okay, so just to give an overview of what is SCP. So essentially, SCP is a very well-established criminology practice that seeks to reduce opportunities in situations for crimes. So the research began decades ago in the 1970s. So today it is very widely and successfully implemented in many countries, including Australia, on a wide range of crimes, ranging from robberies to terrorism and even wildlife crimes. So quickly, SCP essentially comprises 5 key main strategies. As you can see on the slides, on the columns, there are 5 columns. So you can see from the left, column A, increase the efforts, followed by column B, increase the risk, column C, reduce the rewards, column D, reduce provocations, and finally, the last column, remove excuses. And under each of these strategies or columns, there are 5 corresponding SCP techniques. So therefore, leading to a total of 5 times 5, 25 SCP techniques. Of course, I will not elaborate on each of the technique because it's quite lengthy. But suffice to say that actually our research shows that SCP strategies and techniques are very adaptable and relatable to cybersecurity controls. That probably explains why increasingly today there are research attention being paid to look into SCP to prevent cybercrimes. So just to the quick description. So earlier on, we heard that the first column increased the effort. So increase the effort essentially means increasing the efforts for criminals to commit crimes. So to put it on layman terms, mainly it means how to make it more difficult for cyber criminals. So in this case, we can apply corresponding cybersecurity controls, for example, firewalls, password management policy, which I'm sure cybersecurity practitioners, researchers are very familiar with. If you can see the relationship, all these cybersecurity controls actually make it difficult and thereby increasing the efforts for criminals to commit the crimes. And so similarly for the remaining 4 SCP strategies. Again, due to time constraint, I won't mention too much, but you're free to read more from on my paper, which I will show the references later on. Okay, so why then do we use SCP? Now, early on, I hope my colleague Chen Miao could successfully convince you, right, that if you want to manage and prevent cybercrime successfully, it's not sufficient just to look only purely from the angle of cybersecurity, right? Because unfortunately, cybersecurity, we tend to look purely on the technical side. And when you talk to cybersecurity professionals about cybercrime, they tend to mean cyber-focused or cyber-dependent crimes like hacking, DDoS. And conversely, if you were to speak to a criminologist and you talk about cybercrimes, chances are very high they'll be referring to cyber-enabled crimes. For example, stalking, cyber abuse, cyber fraud, so on and so forth. So therefore, if you are convinced by my colleague that if we want to look at cybercrimes holistically, right, we need to combine them. And therefore, when we look into criminology, of course, as a researcher in SCP, I advocate SCP because number one, it has decades of rich research and has proven implementations. And as I've explained earlier on, the strategies and techniques are very adaptable, relevant, relatable to cybersecurity. So therefore, I find that this is the best criminal practice to apply to. And by using SCP, hopefully we can provide a unified and common language for both the cybersecurity practitioner, researchers, and the criminologists to come together to look for a common language to identify intervention solutions to prevent cybercrimes. Because after all, our adversary, the offender, they are not going to make a distinction between cyber-enabled or cyber-dependent or cyber-focused. When they commit a crime, it's a crime. And when they commit a crime, they'll do it to the best of their ability. They will possibly include elements of cyber-enabledness as well as cyber-focus and cyber-dependency. Okay. So for example, nothing stops a very astute cyber stalker to hack in his quest to stalk a person, right? Okay, and our research shows that there are possibly certain insightful SCP research directions. So chiefly among them is to how do we encourage multidisciplinary research in SCP for cybercrime prevention? In other words, how do you make SCP understood by cybersecurity folks, and vice versa? How to make the technical side more easily understood by criminologists. So one way we consider was to develop a common inventory of SCP-based cybersecurity controls. I will show a quick example in the next slide. Essentially, we want to create an inventory where we map or classify cybersecurity controls to SCP strategies and techniques such that it allows any criminologist who may not be familiar with cybersecurity or any cybersecurity professional who may not be very familiar with SCP or criminology to just use the content from the common inventory in a very plug-and-play manner to apply controls, regardless of their initial knowledge and background. Again, I'll briefly describe how we can do this in the subsequent slides. And then to kickstart, to help people from cybersecurity and criminologists to come together in a multidisciplinary manner, we propose an instrument to help facilitate this. Here we call it the SCP-C3 cycle. So the C3 stands for concentrate, comprehend, and consider. And it is based on the 5 key SCP principles, as well as the Plan, Do, Check, Act cycle, PDCA, which I'm sure almost all the IT and cybersecurity professionals are familiar with. So this is an example of how the command inventory could potentially look like. So in my research paper, I looked into classifying ISO 27002 controls. So 27002 has a total of 93 ISO controls. So you can see on the simple table on the right-hand side. So in my paper, I try to classify and justify and explain why each of them should be classified under the left-hand column of the SCP techniques. Again, this is just a quick snapshot because of the limitation of space and time. Later, I'll direct you to the paper for more details. And we envision that this command inventory, hopefully, can be scaled to accommodate other cybersecurity controls from other cybersecurity standards and frameworks, for example, from NIST or MITRE or ISACA. And here is an example of how we could potentially use the SCP-C3 cycle. So in SCP-C3 cycle, the first C stands for concentrate, then followed by comprehend and consider. So what do we mean by concentrate? So number one, we want to first consider and concentrate our attention on a cybercrime of interest. So here in my diagram here, I illustrate a sample of a ransomware, which I believe most, if not all people will agree that ransomware is considered one of the most top, or if not the top cybercrime threat to individuals, organizations, and businesses alike. So once we decide to concentrate our energy on the type of cybercrime, the next step is then to comprehend it. So to comprehend, we suggest modeling it, and there are many ways to model it. For example, one could model it using CyberQ chain. We can model it using the criminology, crime script analysis, or the business process modeling. So once we model, over here in my slide, I modeled it, and you can see that I try to include key activities into rectangles. Right. So once we identify the key activities in the form of rectangles and the direction of the flows, then the next step is then to see whether are they intervention points. So intervention points could potentially occur before a key activity or during a key activity. Right. So in this case, on my left-hand side, maybe potentially a researcher to say, oh, to stop key activity A, where the victim receives ransomware material, perhaps we could try to, let's say, for example, increase the efforts, or which is SCP strategy number 1. And what would be what are the security controls inside SCP strategy 1? That would then the researcher, even if they are not very familiar with cybersecurity controls, could conveniently refer to my common inventory, such as this, and then use it in the plug and play manner. And hopefully this could allow more room and collaboration and interdisciplinary work between researchers, regardless of the fact that they may not necessarily be very familiar with both criminology and cybersecurity. And finally, of course, once they're properly modeled it, then they could then consider the variety of suitable SCP-based controls, which then again could lend itself very well to experiments. For example, using the one that surveys focus studies that Eleanor mentioned earlier on. And the possible impact of our research work could be that we hope that through this common inventory and SCP-C3 cycle, we could allow researchers to look at cybercrimes more holistically, both from the cybersecurity as well as the criminology perspectives, and facilitate interdisciplinary research. Because again, one have to bear in mind that offenders themselves don't make distinctions of this. And so example from the cybersecurity side, perhaps the cyber focus or cyber dependent crimes like ransomware, or even cybersecurity standards like ISO 27002 could be looked at more from the criminology of people point of view, and vice versa for the criminology side. Okay. And that's all for our sharing. And I'd like to acknowledge, of course, my university for my sponsorship, UQ, EAIT, and the School of EECS for the opportunity to do PhDs. And of course, not forgetting our professors and supervisors, Professor Ryan Cole, Lorraine Nazaro, and Dr. John Gilmer, and of course to Kimberly for her assistance in my fieldwork. And here are the papers that I mentioned on where we derived our content for this talk from. Thank you.
Thank you. Any questions to the speaker? Okay, while people are thinking, I have one. I come from cybersecurity background. So in cybersecurity, we already have many vulnerabilities and leads to diverse type of consequences. In the case of cyber-enabled crimes, I believe that from the criminology side, they probably have all different variety of ways of using these consequences in a way to conduct a crime. So I can see that you're trying to build an interface between these two so that these two areas can talk to each other. But for each side, we have so many different possibilities, and similarly for the criminology side. How can you handle that problem?
Yeah, yes. So I think, honestly, one of the key challenges is that both cybersecurity and criminology are very large or broad fields. So large and so broad that you could have an educational program like a degree or master's just for that field. So the content is too voluminous, correct? So therefore, for one researcher from a discipline to switch to the other discipline, sometimes the challenge is too much content to grapple with. That's where, again, our research work try to provide tools to ease. By no means do we say that our tools are comprehensive or altogether. So here, early on in my slides, we propose 3 ways. So 2 ways. So the one is the inventory. All right. So the common inventory essentially controls, because whether from the criminology or the cybersecurity side, at the end of the day, we want to stop the crime in the processes from happening. So which is why looking back, SCP is very suitable because it looks at stopping situational opportunities, which is present in every type of crime, be it physical or cyber type of crimes. But the challenge then is that when we want to stop these, it is difficult for one researcher from one discipline to think about and the other discipline. So for example, for cybersecurity folks, we tend to look at very much on technical side, all right? But then ironically, those who are in cybersecurity, we will think of this saying, they always say humans are the weakest link in cybersecurity, right? But then when we say humans, but we don't look at the human side, which is exactly what the criminologists do look at. And in the SCP strategies, decades of research, more than a century, half a century, they look at the motivations, opportunities that could compel a person to commit a crime. So for example, they distilled into make sure that you increase the effort, increase the risk. And one, particularly in my third paper, I did point out is reducing provocations is something that criminologists look at, but cybersecurity, we don't look at too much. We tend to rely on technical controls. So to quickly explain, I hope that my inventory gives an instrument, and also to help us start the C3 cycle is also another way.
From technical backgrounds, I mean, if we want to do further to use techniques to help in the future, do you see any opportunities?
Yes, most definitely. I think the first way, again, trying to advertise my C3 cycle, is that actually I really advocate that we should start breaking down cybercrimes holistically. If you want to prevent something, you need to understand it first, right? So to understand in a structured manner, scientific manner, modeling is the best, because you can then see what are the key activities. And there are many modeling techniques that are up to everybody's comfort. For example, criminologists may like to use crime script, fine. For IT guys, they may want to use CyberQ chain. Fine, doesn't matter. So you model it. Then once you model it, then you look into possible intervention points. All right. And then if you're just a cybersecurity guy, maybe you just just consider cybersecurity controls. But then again, as I mentioned, you may miss out the human or criminology element. And vice versa, if you're a criminologist, you may want to stop a crime, but you are not very confident about cybersecurity controls, which is quite understandable, right? So hopefully using this cycle, where you break it down and then you apply the inventory. Hopefully this could be a step towards, in our future work we do, once we introduce the inventory and a cycle, we want to come up with case studies. So for example, ransomware, cyber fraud, data breaches, or cyber stalking. How can we prevent it holistically using both instruments?
Thank you. Oh, okay. Questions?
Thank you for your presentation. It was really interesting. Just considering with a lot of crimes, how the context and the environment in which they committed differs. I understand that your suggestion is using the inventory to implement the controls. Have you found any difficulty in the use of some of those controls in whereby the environment or the context doesn't work in the use of implementing that control?
Okay. Okay. To be more precise, currently we haven't looked into the actual application. That's for future research work. But of course, in my paper, we did do a simple illustration of how it could be potentially used. But to be more precise, yeah, definitely we need more research work to look at. But B, having said so, by itself, SCP is remarkably successful on a physical crime, and we know physical crime has many conditions and environments. But yet, despite the variety of conditions and environments, they have been successful. So therefore, on the conceptual side, I don't see a reason why we cannot apply it to the cybercrime itself, even although the conditions may differ, because ultimately they could still be certain general structure that applies for the cybercrime.
Thank you. One more question. I think first.
As a criminologist, I'm going to ask you some theory-related question. So when we talk about situational crime prevention, it is a very physical, place-based mechanism. And we look at obviously deterring the offender, we look at managing places, and then we have the impact on potential victims and hardening them. When we have a landscape, and this is kind of referring to your second paper on the systematic review, do we find that people's personas online and how they identify themselves, and I'm going to say naivety, but that's probably the wrong word. How does that impact how we can translate the effectiveness of these interventions actually online? Because it is a physical theory.
Okay. So number one, the second paper that you mentioned, when we did the review, what we did is we just did a literature review. Okay. Of course, we used the Prisma methodology to ensure there's certain structure for reproducibility. So when we did the literature review over 3 research database, ACM, IEEE, because they're simply famous in computer science, cybersecurity, and criminal justice abstracts. Unfortunately, interestingly also, actually there was a dearth of research on using SCP to prevent cybercrimes. In fact, our literature review shows maybe less than only 10% or 12% of the articles discuss SCP. So, which is probably why I'm a PhD student. It's a good direction for me to go to. So unfortunately, the review itself, based on this, doesn't show much content. So unfortunately, I can't answer that question, your question very well. So it is still, in my opinion, in its initial stages, trying. Actually, along the way, my review indicate, actually the criminologists, they also agree and they understand. They keep saying, we need to have a multidisciplinary research between But yet, when I read, personally, this is my view, when I read, I don't see any concrete. Everybody say, yeah, there's a need. Everybody says, yeah, we should collaborate, but how to? Any instruments, there's a, in my opinion, the dearth. Which is why I'm trying to attempt to overcome this. And the first step is to consider waste. And because my background is more cybersecurity, so therefore I immediately, cybersecurity, we look at standards, controls. So I look at the controls and then I try to map it. So that's where the inspiration for the inventory comes in. I'm so sorry, I can't answer that question very well.
That's good. It means we can work together in the future. So I
Yes,
like
yes,
it. It's great.
Yes, yes.
Thank you for your presentation. Would you ever consider using routine activity theory as a way to like apply or prevent cyber crimes instead of SCP?
Actually, as one of SCP has about 4 key theoretical principles and background. Routine activity, RAT, is actually one of it. So to answer your question directly, yes, because RAT is actually SCP includes RAT as part of its theoretical background. All right. In fact, my third paper we just submitted, we even looked into expanding the RAT crime triangle to include the cyberspace site. So the answer is yes. But having said so, to me, from my background as a cybersecurity, I think to cybersecurity people, one very important thing is that we rely a lot on cybersecurity standards and controls to implement. Because I work as a cybersecurity manager, 80% of my time is about ensuring controls. So in the perspective of control, when I read the initial, I find SCP is more relevant to me. And when I delve deeper, I'm even more convinced because increase the effort, increase the risk, all these are very, it pretty much describes what cybersecurity professionals do in the cyberspace. Yeah.
Okay, thank you.
Okay, let's thank the speaker again.
Thank you, thank you.
Thank you, everyone. That's the end of this session. Come to the next one.
Yeah, hello everyone. So yeah, we have 5 minutes break before we have the last session for today. Okay, we come back at 3. Okay, everyone. We're gonna have the last session for the UQ Cyber Conference this time. So in this session, we're gonna have two speakers, Ivano and Nibel. So each talk gonna last for 20 minutes, and the first talk is evidence-based decision-making in cybersecurity, comparison between research and practice, given by Dr. Ivano Bengiovanni. So Ivano?
Yeah. Thanks, everyone. I was actually thinking my son would join me in presenting, but apparently find a nice distraction over there with his little board. So I'm probably gonna do it by myself, but I want to acknowledge him as co-author of this presentation. So my name is Ivano Bongiovanni. I'm a lecturer at the business school. So obviously non-technical focus, and really most of my work is in the GRC space. I have a background as a risk manager. I'm an ex-police officer. I used to work as a security manager for a large organization. So that's a little bit my background, and I'm part of UQ Cyber, obviously, as someone that works with business. So really looking into the risk management side of cybersecurity. And my son, well, he goes to daycare. That's his resume. So today's talk is going to be divided in three parts. I'm going to talk a little bit about this piece of research. Sorry, I forgot to mention. This is one of the UQ Cyber Seed funding pieces of research. This program that we have at UQ, where there's obviously grants and money given for researchers to partner with industry partners and get some multidisciplinary research going. So I'm going to talk about some of the preliminary findings from this piece of research, in particular what we found so far and where we're going to go next. Now the research team is the following one. As you can see, quite a bit research team, and it's interesting to see that we do have very different backgrounds. Mine, as I said, is risk management, and we have a colleague from the business school who is an expert in leadership. Professor John Swinson is a lawyer, so he's got that legal background. Ryan, no need for further introductions on Ryan, and then also we have somebody from the School of Psychology to really cover the human side of things in what we're doing. We have partnered with Averture. I don't know if you're familiar with this company. It's a Sydney-based startup. They have this product called Cyber HQ, which is pretty much a dashboard. Speaking of cyber resilience, as we were talking about before, that kind of really measures cyber resilience and really gives peace of mind to executives when it comes to making decisions in cybersecurity. All right. So how do I know how much money I should spend in cyber? What type of chain of command I should put in place? What is the best organizational structure? Should I hire one more analyst? Or should I outsource the stuff, and so on and so forth? And obviously, a lot of what they do is giving visibility to some of these decisions, because as you understand, especially when you blend in the technical side of things and the non-technical side of things, communication is fundamental. And what we're really trying to work is, how do we make whatever that piece of visibility is more evidence-based? Why did we start looking into this project? Because speaking with practitioners, which is something that we do really on a daily basis, we did find out that there's some areas that would probably be worthwhile further unpacking to possibly come up with some products / services that could actually help companies make more informed decisions in cybersecurity. Okay? It does sound like there's something different about making decisions in cyber. If anything, especially for those of you that come from a risk management background, if anything, because at the end of the day, we're still talking about loss prevention. And as you know, from a business perspective, loss prevention has this enormous dilemma that goes by, I spend a lot of money, and in the best case, nothing happens. All right. And obviously, from a business perspective, cost center, wasted money, potentially, right? Especially when you have to make decisions between, do I spend money to cover for losses, or do I spend money to gain more customers and expand my business, and so on and so forth. All right. Influence of the media, another big thing. Needless to say, oftentimes, for example, boards start freaking out about cybersecurity because the day before they read that, you know, the likes of Optas, Medibank, and so on and so forth have been hacked. So they start thinking, should we worry about it as well? There's a lot of reliance on individual experience, which is actually great because companies that can rely on people that have a massive track record in cybersecurity are in a good place. But what happens when those people leave, go to work for another company, and so on and so forth? And a bunch of other quite interesting aspects that we have identified and we saw when we started talking about this research. Probably the one that is closer to home for me is the second last one that says cyber risk management is that an art dressed up as science. Okay, oftentimes, if you think of heat maps, semi-quantitative cyber risk assessment, and so on and so forth, there is a lot of willingness to kind of make everybody feel comfortable with what we're doing in cybersecurity. But then the real question is that scientific? Is that empirical? How do you go by estimated likelihood and consequences, which, as we probably know, it's one of the trickiest things ever. And needless to say, a lot of gut feeling goes in there. So we kind of started talking to some of these companies. So the way in which we designed the project, so it's qualitative, right? So we're doing interviews. We're going to do probably focus groups and a survey. But at the moment, we've done a bunch of interviews. And we actually sliced and diced companies in 3 levels, the typical military approach to these concepts. The strategic level, and you have some examples of job titles of people that we are interviewing. The tactical level, which is pretty much second line of defense, if you're familiar with the concept, really compliance and GRC space, and how cyber connects with the overall risk management in the company, and then the operational side of things, which is your really operational security functions. We are interviewing 2 people per level. And if you think about it, 6 people per organization is not much overall. But then if you think about the size of the cybersecurity departments of some of these companies, it's actually quite a lot. And I don't know if you're familiar with it, but if somebody ever asks you, what is the average number of people in cybersecurity in organizations? Very rough way to calculate that is think of 10% of the staff members and the organizational resources are utilized in IT. Another 10% of 10% is what staff members and resources are in cybersecurity. Rough approximation, obviously it differs from many companies, but 10% of 10% is a way to calculate how many cyber people are. So if you think about, for example, a company of 600 people, we're talking about 6 people in cybersecurity, which is actually quite small. And it's one of the things that I keep banging on when I present to cyber practitioners, because oftentimes we really just talk to each other and we get cyber, we love cyber and we think that cyber is everything. But at the end of the day, if you put it in the bigger picture, within each organization, we are a tiny part, we are a tiny cog of the whole machinery. And we need to keep that in mind, all right? So we did these interviews. We actually, so far we've done 3 companies, 2 in the utility and energy space, 1 large hospital. And the purpose was really trying to understand what is the status quo on cybersecurity decision-making? How do you make decisions? What are the factors that influence how you make decisions in cyber? And again, by decisions, I mean investments, hiring people, do we pay if we get breached in case of ransomware and so on and so forth? And what could you improve? So that was really the underlying question. Obviously, we are researchers, and so we started with some literature review. Luckily, we had somebody in the team that is very good at doing this, so she's done an amazing job. And she's actually put together this model that is an analysis of gray and academic literature that tells us how do companies make decisions in general, okay, with a specific focus on cybersecurity. So I'm not going to go through the model too much because it gets boring and theoretical. Roughly speaking, whatever you see in gray is macro factors that impact cyber decisions, and the green ones are the procedural steps into how companies ought to go by making decisions in cybersecurity. And you can already see there's obviously environmental aspects that influence decisions, organizational aspects, needless to say, size is a big one, internal cybersecurity approaches, and all of that fits into what is the posture of the organization, blah, 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 a number of steps. Then you have one last thing that gets in the way, which is individual factors. So if the individual that makes decisions has some particular behavioral aspects, thank God we have somebody from psychology that helps us unpack that. That could actually influence how the decision is made and what decision is, right? So we actually elaborated this. We're talking about some of these things with the companies. In each company, what we did is a comparison between the literature and what we mapped their decisions are from the interviews we conducted, okay? And when we see gaps, that's an area where we recommend improvements, okay? What did we ask? 4 main areas we investigated. What happens in terms of cyber decisions at the industry level? And again, I mentioned utilities and healthcare, highly regulated industries. Obviously, there's a lot happening at the industry level that goes beyond what organizations want or don't want to do. At the organizational level, at the team level, so this is really mainly the cybersecurity team and the departments that mainly interact with that team, or the functional areas that interact with that team, risk management, for example, board of directors, and so on and so forth. And lastly, what do you do when you, as an individual, make decisions in cybersecurity? Now, a couple of preliminary findings. As I said, 18 interviews is not much in terms of sample, but it does give us an understanding of what really is going on in these 3 companies. First, some obvious ones. Influence of regulations, obviously, is there. We've been hearing some talks, and in particular, Rob Champion mentioned that yesterday when we're talking about, it was talking about the focus on compliance versus the focus on performance. Sometimes just going on and banging on compliance is not enough to ensure performance from a cyber perspective is there. Obviously, needless to say, a lot of companies are worried about compliance because if they don't comply, that means fine, that means a lot of very nasty things happening.
Information sharing tends to be good, but not very formalized. So obviously, it does depend a lot on the industry in which you're operating. Some industries are great, and I can give the example of the water industry here in Queensland, being very good at putting together companies and creating a safe space for them to share information. And by sharing information, oftentimes I'm really talking about informal threat intelligence. The role of managed security providers or MSSPs is huge. And when we talk with people that are at the operational and the tactical level, they do emphasize the fact that they do rely a lot on what MSPs tell them, okay? If the MSP tells me, hey, you should invest here, probably that's evidence-based and probably I'm gonna go and invest there, all right? If they say don't do that, probably we're not gonna do that, especially at the tactical and the operational level. Strategic people who are people that have been working in cyber for a number of years and have seen a lot of different things and have conversations at the C-suite level tend to be less influenced by MSPs. A couple of other ones, probably I'm just quickly going to go on the organization side of things. Chain of command in 2023 is still a thing, all right? And that can be good or bad, it really depends. Probably great in business as usual, maybe not as great in business not as usual when you do need to have a little bit more agility, but that's another ball game. Size does matter, is what I said before. I mean, obviously, when you have 6 people out of 600 that by design care about cybersecurity, it does become quite difficult for people to get decision across the board. Again, oftentimes the CFO is the person that pushes back, because guess what? If you put money towards loss prevention, you're not going to be maybe able to use that money towards other areas that actually help expand the business. What else? Team, probably, the significant reliance on staff expertise and experience, which is a problem when people leave. All right, and we see it a lot in Queensland. There's a massive talent drain. The best talents tend to go somewhere else. And if you look at some industries, obviously I'm thinking public sector or not to mention not for profit. Well, that's a massive issue there, because when they go and work for private companies, they make a lot more money. Why would they stay and work for NFPs and public sector? They do need to kind of work on other type of drivers than the monetary incentives. And the individual one, probably the most relevant one there would be emphasizing the fact that there is a space for groupthink, especially when the other people you make decisions with are always the 6 same people. You tend to talk to each other and kind of really build that way of thinking that it's always the same. And challenging that way of thinking can be very difficult. Now, I have just emphasized the main elements. Obviously, it's not all bad. In the organizations that we interviewed, actually, overall, we kind of noticed a good level of resilience from that perspective and an effective kind of system in place to make decisions. We really just identified what the areas for improvement are. Now, what's going to happen next? We're aiming actually and getting 3 more organizations involved. And as you can understand, especially when cybersecurity departments are so small or similar departments are so small, it is very difficult to get people offline, even if it's just for an hour to run an interview. So we have been kind of struggling a little bit with uptake, not because companies are not interested, because obviously this is an academic research, but personally, the first output is a report for the organization, okay? And we were talking about how do we do good research with companies. I'm a big fan of the fact that we need to give something back. We can't just ask companies to give us some time, and then we do research and something happens and a paper gets published. We kind of need to up our game a little bit from that perspective. So first output is an organizational report. I don't even worry about the academic publication just yet. Hopefully Ryan didn't hear what I just said. And then possibly also creating a large-scale survey to test some of the hypotheses that we have built across these 6 organizations. And obviously, here you go, a piece of academic research, an overall benchmark across the 6 companies, all right? And then obviously the idea is what do we make of all of this? And one of the main challenges that we identified is that companies are quite compartmentalized. So operational and technical and strategic don't really have that full stack type of approach and visibility into how they go by making cyber decisions. So can we build something that helps them have visibility? There was a lot of conversation around visibility, and people complain about the fact that sometimes decisions are made somewhere in the organization and they don't really know where that somewhere is. Okay, so how do we build some more visibility on that? Obviously, when I mention visibility, probably most of you have thought dashboard. So one way could actually be one way could actually be just simply synthesizing a framework. Another thing that I'm seeing possibly originating from this research is actually almost like an approach. Okay, how can we help these companies build a method for them to socialize decisions in cybersecurity, to talk about the factors that influence how they make decisions, so that overall the cyber performance is improved. Now, for those of you that do work for companies, a couple of things and a couple of questions, and based on what we've done so far, might be interesting actually asking yourselves. The first one is probably one of the most important ones, and it's something that I keep hearing when I talk with companies, not just in this piece of research. This difficulty of companies to identify, how do I train people at the operational level to get to the tactical and then get to the strategic level, okay? And that is something that is oftentimes a limitation of a lot of companies, because, you know, if they hire you as a SOC, they're going to train you to be a good SOC. A SOC analyst, for example, in the SOC. And how do you go by second line of defense, or I don't know, if you're interested in working in the GRC space, going into the GRC space. Not so much possibly for the strategic level, in that, you know, what is the next job after being a CISO or a CIO? I don't know, that's a really an open question. It's something I've been asking a lot around, and there's various different answers to that. And again, some other questions, maybe I'm not going to go through all of them, otherwise it's going to take us forever. Have a look at them if there's anyone that you're interested in knowing a little bit more about. Happy to answer at the end. Second last slide, some recommendations that we have provided to these companies. For a starting from the basics, as in reflect a little bit more about you go by making decisions in cyber, could actually be quite interesting. And we, in all of those organizations, we found that when we stepped in and started asking those questions, a lot of people said, actually, we never thought about this. Okay, which is okay, because, you know, especially in cyber, you do get consumed by the daily operations, but, you know, possibly that could be a good way to start building some conversations around some of these topics. Promoting membership in professional cybersecurity networks, especially at the operational level. That was actually another one. Strategic and tactical people are great and are very passionate about being members of professional organizations. At the operational level, it was more based on the individual and their interest. And needless to say, we know that in cyber, being part of solid professional networks is a great first step into building and developing as a professional, okay? Because it teaches you a lot of things, and you can really leverage peers' overview and insights into being a good cyber professional. Ensuring consistency for information flows. Gap analysis, obviously those companies do them. One of the things that they mentioned was that, well, sometimes it's not systematic and very formalized. And the last one is my favorite one. What metrics do you utilize for cyber risk assessment? And a lot of people said, well, if we don't have a data breach, that's our metric. Great, but probably there might be interested in doing more. And they actually told us that they would love to do more. So building labs to create relevant cyber risk metrics, that would actually be a great thing. Final takeaway, and I promise I'm done. Oftentimes it's really about building the right method and not going there and giving these companies a solution. And that's what we're probably working towards with this project. That's it. Any questions?
Yeah, thank you, Ivano. Any questions to Ivano? Okay, then I give a quick one, Ivano. I think we have some questions from online.
Yeah, I saw that there was something. Do you want me to pop it up? No, I think somebody's. Or was it me? All right, sorry, the mouse is a little bit. Let me just exit this. And you want to ask your question in the meantime, and I'll try and pick this up.
Yeah, if I have some question online,
I
I
think it
we give
was-
the opportunity to online people.
Simon Stam, common jobs after size and gardener, woodworking, shredding specialist, actually anything. All right, yeah, that's a good one, Simon. Thanks. As zero ICT and format, yeah, good.
Yeah,
one.
Ivan,
And that speaks a lot.
repeat the question.
Yeah, sorry. The question, Simon, is actually mainly a joke. Simon suggested, what is the next job after being a CISO? A gardener, woodworking, shredding specialist, anything that has zero ICT involvement. Appreciate that. And, we know there's a lot of pressure, psychological on CISOs these days, and there's a lot of turn around. So that's good. Thanks for that. Did you have a question?
Yeah, Ivan, my question is, after you, conduct so much into conversation with the industry people, do you see any, those advanced technology like AI or currently those LLM, large language models, can play a role in the decision making for those companies? Because we know it's a costly process, right, for them to set up an organization, set up specialized personnel to do this.
Yeah, that's a very good question. And I think probably, certainly, yes. The answer would be yes, building more more evidence to make decisions. Obviously, one of the things that came in terms of the factors that impact how they make decisions is cyber threat intelligence. Okay, so if they do have reliable information, or what they believe it's reliable information about what are the next big threats, that comes into play into making decisions. So certainly automating that and making it more reliable 100%. The point is that was just actually one factor, okay? And I would argue that you might have, let's say, very reliable threat intelligence. If the day after something big in the media pops up that counters what threat intelligence says, I would argue that probably the board is still going to make the decision in a different direction, right? And that's for a number of factors, and I might be wrong. But at this level of maturity, probably we're not there just yet. So certainly there is that, but there's also a piece of education that we need to do. Yeah.
Okay, thanks, Ivano.
Thanks.
If no more questions, oh yeah.
Thank you, Ivano, for the presentation. There seems that a lot of gaps between cybersecurity and the enterprise. So even though we are aware that so many sophisticated attacks in the past few years, but it doesn't really change the BOD perspective, how to handle or how to manage this situation. But they tend to be reactive instead of proactive. So do you think this, I don't know how to call it, like characteristic or behavior of the BOD, is there anything to do with regulation that probably hold them back? Because holding a title as a board of director is not only prestige, but also there is something behind it that I learned from the law on the regulation that attached to their title.
Yeah, that's a very good point. Well, first, as a start, probably we were lucky in that the companies that we have interviewed so far do have established information flows in between the three different levels in terms of making decisions. Obviously, the role of the board was a big one, and all of them said, our board is on board, okay, if I can use that term. And there are conversations around the importance of cybersecurity and so on and so forth. So that was good. Probably if with other organizations, they might not have that level of maturity. On the other hand, obviously, it is very difficult for boards to engage in a topic that is not really their bread and butter from that perspective. And I always mention this piece of statistics. A study by ASA in 2020 has shown that only 3% of Australian board members have a STEM background, not just an IT or cyber background, a STEM background, 3%, which is very, very low. Now, that doesn't mean that to be able and confident to talk about cybersecurity, you need to have a STEM background, but it's a good proxy, right? It's a good starting point. So again, it's a piece of conversation that needs to happen. Regulations are certainly ramping up the game, right? ASIC has already said they're going to go after, and they've already started doing it, but you just need to look at the class actions that are around there now after those data breaches. They already said they're going to go after boards a little bit more and try and make them accountable. At the end of the day, managing is not the board's job. They are there to steer and to oversee. And again, I think as cyber professionals and researchers in cyber, I think we can actually help in upping the game beyond what regulations tell us. And again, regulations are always playing catch up anyway. So we can probably push things a little bit further. Yeah.
Thanks, Ivano. So due to the time limitation, I may leave you to have offline discussion with Ivano if you have other questions. So yeah, everyone, please join me to thank Ivano again.
And my son as well for being so good.
Yeah, our next speaker is Dr. Naipeng Dong. She's gonna give us a talk on her cyber seed funding formal verification of post-quantum cryptographic primitives. Yeah, Naipeng, please.
Thank you. So in this project, we are mainly investigating into the post-quantum cryptography primitives using the method called formal verification, or introduce what they are. First of all, okay. Yeah, first of all, quantum computers. Computers are devices that handle information. In classical computer, the smallest unit for information is called a bit. So a bit can either be 0 or 1 at a time, cannot be both at the same time. But in quantum computers, the smallest one is called qubits. In a qubit can be 0 and 1 at the same time. So because of that, quantum computers are using the mathematics of quantum mechanism. It can handle many more states at the same time. So that's why we heard that quantum computers are more efficient. But what I want to see here is that quantum computer are not just a simple replacement of classical computers with faster speed, but it provides an alternative way of solving problems. So the picture here is a screenshot, comes from, oh, I can't do anything, comes from a YouTube video. And the green part in the middle, that's our map. So we can see there are 2 islands. On top is, suppose the problem we want to solve is coming from one island to the other island. And then the green area is our map. So originally, the way is we build a bridge and then we come up with ways we walk there. And then later we found that riding a horse is more efficient. And later we built even better routes and then we invented cars. So, but no matter it's a human walking, riding a horse, or going by car, we're following exactly the same map. We're following exactly the same road. So quantum computers is not a faster car, but rather than like a boat. It expands our map to within the blue part with the sea. It's more like a boat. From one destination to the other, we don't need to go across the bridge. We don't need to go via the land. Instead, we can go via the sea. And since the map is enlarged, we may find unidentified islands. So far, we do not have complete understanding of the capabilities of quantum computers. We still have this undiscovered land. And the development of quantum computers is very fast. The idea was proposed in 1982, and then roughly more than 10 years later, in 1998, the first 2 qubits quantum computer is realized. In 2020, 7 qubits, 2016, 12 qubits, 2011, 14 qubits, 2017, IBM developed a quantum computer that has 50 qubits. 2018, Google joins this competition with 72 qubits, and 2020, IBM catch up with a computer of 65 qubits. And recently, recent 3 years, it's even more faster. 2021, a computer with 127 qubits. 2022, IBM achieved 433 qubits. And their goal is by the end of this year, they want to achieve 1,127 qubits. 1,000 qubits is a milestone that's set up. Very often people ask the questions, is that big enough? Is 1,000 qubits efficient enough compared to our classical high performance computer? So the answer is no. 1,000 qubits is too small. It's not enough compared to our classical high performance computer, and it's not enough to break cryptography. But why are we still scared of quantum computers? Well, of course, there's a bright side, means that quantum computers are actually quite efficient. So the reason we are scared about that is called the Moore's law. In the classical computer, we see this trend representing here. The Moore's law said the number of transistors on the microchips double every 2 years. So it means that it says that the hardware improves very fast. And this is the trend of qubits. And this is even improving faster. And then we don't know how many years. It maybe just take a very short while such that we can reach enough qubits to break cryptography. And again, we have undiscovered island, means that it could be some smart person come up with a smart algorithm with just a little of qubits, and then we can solve complicated problems. And the relevance to cryptography is because the foundation of cryptography is the hardness assumptions of mathematical problems. By hardness, we actually means that currently there's no efficient algorithms that we can solve the problem. We have this condition, current algorithms. Current algorithms is current software and current hardware. But with quantum computer, we may have smarter hardware and smarter software. And on the picture on the right-hand side, the P, the green one, is the problems that can be solved with classical computers, including the high-performance computers. And then you can see the blue one is the quantum computers. So quantum computer can solve problems that cannot be solved with the classical computers. And some of those hard problems that cryptography is based on is also need to be outside of the P circle, but some of them is within the circle of quantum computers. So one of the example is the factoring problems. The problem is we give n, that's a multiplication of P and Q, where P and Q are large prime numbers. The challenge is to find such a P and a Q. This problem is very easy when the number is low. For example, if I tell you n equals 21, you can immediately tell me P and Q equals 2, 3, and 7. But the problem is when n, P, and Q are very large, this cannot be solved efficiently by classical computers, but quantum computers can solve it efficiently. An example is that factoring a 600-digit number with the state-of-the-art classical techniques, that would require about 1 billion years. But a large quantum computer may only take a few hours. But here, large quantum computers 1,000 qubits is definitely not enough. And this is done by an algorithm called Shor's algorithm, and that's proposed in 1994. This is a hybrid one. It's actually only partially on quantum computers. The pre-processing and post-processing is still on the classical one. Essentially, it reduced the factoring problem to the problem of order finding. And then quantum computer is very efficient solving order finding problems using a quantum frontier transformers. The implication here is that factoring can easily solved, means that any cryptography that relies on factoring problems is not secure. For example, the ISA encryption or digital signature schemes that are widely used in our daily life. For example, our bank, right? And also it breaks similar hard problems like the digital log problems and eclipse curve cryptography. The second well-known algorithm, quantum algorithm, is proposed in 1996 called the Grover's algorithm. This one, it speed up an unstructured search problem. Because quantum computer can do tests simultaneously. The implication on cryptography is that it makes brute force attack on symmetric encryptions such as AES or SHA easier using a known plaintext attack. Known plaintext attack means that if the attacker could collect all the historical ciphertext and plaintext, means that your message and the encrypted message, and then they can try to all the possible keys. That's a brute force attack until you find the correct key. And you know that correct key is also going to be used in the later on encryptions. And if he can guess this key, and all your information encrypted with this key is leaked. And with Grover's algorithm, 128 base key, that's a tradition. Normally, currently what we are using will be broken in 2 to the power of 64 trials with 128 qubits. And the 256-bit key could be broken in 2 to the power of 128 trials with 256 qubits. So to compare, in comparison, 128-bit key and 256-bit key and the brute force in classical computer takes millions of years. So it means that any real world applications using this cryptography is either broken or their security is reduced. For example, the VPN, our email protocols, web services, even the TLS protocols, and also like blockchain applications or any other software mobile applications. So that's why that's the motivation of NIST calling for submissions of post-quantum cryptography algorithm. By the way, post-quantum algorithm is algorithms running on our classical computer. It's not running on quantum computers, but it's a safe against quantum computers. Means that it's a safe even the attacker has a quantum computer. And the NIST call for post-quantum cryptography algorithms starts from 2016. The first rounds of computation is in 2017, second round 2019, third round 2020. Just after 6 years of computation. By computation, we mean that people try to attack those cryptography to test whether it's secure or not. After 6 years of testing, in 2020, July 5th, NIST announced the first round of winner. There are 4 post-quantum cryptography announced. One is the key establishment. 3 of them are signatures. Among those 4 algorithms, 3 are based on lattice. Lattice is the hard problem that are based on, and one of them is based on hash. so we can see that, well, there are other post-quantum algorithms. During our survey, we found people keep proposing new post-quantum algorithms. Very often it's specialized in certain domains. For example, IoT, where the computing resources are limited. In general, there are 5 classes. Each class is a type of hard problems. And all these systems are claimed to be resistant to classical and quantum computers. By seeing that, it simply means nobody has figured out a way to apply Shor's algorithm to these systems. But it's just that nobody didn't figure out yet. It could be someone later figure out a way to apply it, or could be some other people create yet another algorithm that could break it. So is there a better attack? The answer is maybe. And this is why we need to invest a lot of time and effort in doing cryptanalysis. We try to break the algorithms before the attacker doing it. To give an example, that's taking the NIST computation as an example. The first round, 82 post-quantum algorithms were submitted. Among them, 69 are considered complete enough for the later on consideration. And then in the first round, 25 are removed because they are attacked badly. And for second round, another 8 was removed because they are flawed again. To our surprise, just before the round 3, the 2020 announcement of the final decision, New published the cryptanalysis results just moments or month before the finalists, and at least 4 of them are attacked. Well, the final 4 is just that we don't know whether there's attack yet. So further analysis is needed. And one of the surprising example is the Rainbow, one of the most popular post-quantum algorithm. And this was found completely broken. It's not broken with quantum computers. It's broken with a laptop in just a few days. So this hopefully motivates you the importance of cryptanalysis. And unfortunately, this cryptanalysis or the proof of those security of post-quantum algorithms is traditionally manual. And we know that manual proof is error prone. And even there is a proof, it's difficult to check whether it's correct because it's pages. It's difficult to read and understand. So learning from classical cryptography, there has been developed techniques to do formal verification. Formal verification, especially automated or semi-automated verification. In that way, we use computers to help with the proof. And it takes a cryptography algorithm, a desired security property, and what type of attackers we consider. And we represent in a way that computer can understand. And then computer can do the help to do the reasoning. And then at the end, the tool hopefully give us proofs or disproofs. So this technique has been successfully applied to classical computers, classical cryptography on 3 levels: cryptography primitives, that's the cryptography algorithms we talked about, could be cryptography protocols, could be cryptography applications. And so for post-quantum algorithm, the existing works is trying to lifting this existing techniques for classical cryptography to post-quantum cryptography. We found 2 lines of research. One is on the level of cryptography primitives. A tool or approach is proposed called ECPQC in 2021. It's very recent. This technique is based on a way called game verification. For a cryptography primitive, on one side, that's the game 0 there. And then we have a hard problem, that's the base. So we model in this approach, we model the hard problem as game N. And then what the technique is trying to prove, this is equivalent in the sense whether attacker can gain any advantage in guessing some bits. If it's not, it's equivalent. Otherwise, we try to prove an arrow bound. But directly proving the equivalence or the arrow bound between game 0 and game N is very difficult. What people do is propose intermediate games and trying to prove the two neighbor games are equivalent or bounded with certain arrows. And this one, the game is proposed by an analyst manually. And then this is semi-automated. The proof of the equivalence of two games we can use theorem proving. And this easy PQC is based on this technique, trying to lift it by adding quantum quantum adversary capabilities and defining new proof-based assumptions. But the gap is very obvious. It's not fully automated. Even proving two games are equivalent, analysts needs to understand theorem proving. This is interactive proofs. And also we found that the easy PQC is very difficult to use. Okay. So the other one is on the cryptography protocols. This one used a classical logic and its implementations. On top of that, it proposed a PQBC logic that was sound with respect to quantum attackers. And this is implemented by modifying the original prover. So at the end, what we did with this project, we did a systematic review of the formal verification techniques for both classical cryptography and post-quantum cryptography. And then we currently ongoing work is doing a case study on the cryptography primitive levels using the easy PQC. And we found that it's not easy to use, it's not fully automated. So next step, we are going to develop user-friendly tools so that non-expertise can use, and so that everyone can check whether the cryptography primitives they are using is correct or not. And in addition, we also did a survey, particularly focusing on post-quantum zero-knowledge proof in blockchain applications. And we identified this new application on the cryptography protocols. We didn't do anything yet. It could be very interesting to explore those techniques. And finally, those two existing works, one proposed in 2021, the other proposed in 2022, which is very recent. They are just still focused on the design levels. Means that we don't know whether we have a secure implementation of those post-quantum cryptography or protocols. So normally in software engineering, we use that as a library, but we don't know whether there is a secure library or not. So it will be very interesting to either build secure libraries or checking whether those libraries are secure or not. Those are the references. That's the talk. Thank you very much.
Thank you, Nipun. Yeah, any questions to Nipun? Yeah, Mark.
Seems like a really hard problem because you're, well, you've got a new kind of hardware and you're trying to prove there is no way of solving a problem. It's not like you haven't even got just prime factorization proving that it can't be done. You know, you've got, yeah, you're trying to prove the non-existence of something.
Right, that's a good question. I probably need to make it clearer. We're not trying to prove the non-existence of algorithms to the hard problem. This is one problem, and then that probably relies on the expertise of quantum computer capability to see whether some hard problems can be broken or not. But what we are trying to do here is we assume those hardness problems are not broken. For example, the lattice currently no one found is broken. So we assume this is correct. But that yet, even we assume that's correct, it's not broken. There are errors when we're trying to build the cryptography schemes based on this hardness problem. So what we try to prove here is that the cryptography scheme does not introduce advantages for attacker to break the cryptography.
Okay, so you're trying to prove the correctness of an implementation of the lattice-based.
Yes,
thing.
not the implementation, that like the design.
Yeah,
For example, in we know that factoring is a problem, or lattice is a hardness problem, and then but still for a signature we need to have a key generation and then encryption schemes, signature schemes, signature checking schemes, and those are mathematical computations. So what we will try to prove is that those mathematical calculations will not give attacker advantage to guess what the message is or what the key is.
Thanks.
Thank you for the question.
Smart. Yeah, we can take a quick one.
Hello. So when we speak about like 400 qubits and 1000 qubits, is it the architecture or anything else? Because I mean, in classical computers, we speak about 32-bit architecture and 64-bit architecture. So in terms of qubit, is it architecture or is it the memory?
I'm not sure whether my answer is correct or not, but it's probably a implemented hardware computers that has been built that they can handle that many bits at the same time. Yeah, it's quite a different from I'm not sure I understand it completely how the quantum computer works. But maybe Konstantin will be a better person who can answer that. I guess that's a hardware problem. That's probably not an architecture problem, but I'm not sure. My answer may not be correct.
Okay, thank you.
Yeah, thank you, Naipeng. Yeah, everyone, please join me to thank Naipeng.
Okay.
So we're gonna end this session and thank both speakers again. I'm gonna hand over to Dan.
Yeah, I'd like to present the best presentation award. So it was very competitive. Everyone did really well at this time. And so finally we made a decision. So we have two categories. One is the best student presentation award, and two is the best UQ Cyber seed funding presentation award. Now, let me announce the best student presentation award. It goes to Wen Nujan. So she talked about honeypot. Maybe, I don't know, maybe take a photo until then. Yeah, you are the one. Can you stand up? Yeah, please. Yeah. Henry was talking about honeypot for industrial control system. Yeah, thank you. Now, yeah, you missed down. Yeah, okay. The second category is the best UQ Cyber Seed Funding Presentation Award. So it's also very competitive. We have all the nice talks, and I really enjoyed everything. But we only have one or two, right? So the first one goes to Professor Janet Willis. She was talking about secure digital identity for older Australians. Yeah. Janet is not here, but that's the thing. Congratulations, Janet. And because it was very tight, so we have one more. And run-up award, it goes to Associate Professor Gianluca Di Martini, that the UQ Lesson and Data Dashboard. Okay, now I'd like to hand over this mic to Ryan. Yeah, right.
Thank you, and thanks to the anonymous industry panel for doing the judging of the presentation awards. Yeah. And thanks to Dan for running that as well.
Same slide here, same slide here. Yeah.
So congratulations to the awardees. We don't have a a Tesla car or something. You will be getting a certificate. Yeah. So I want to thank the people who put this together. First, the program chairs, Guan Dong Bai and Guo Wei Yang. If you can stand up, that'd be great. And then the industry liaison chair, Grant. He was here. Oh, left 10 minutes ago. Oh, okay. He's the senior manager for industry and development for us. So thanks to him. And also Kana Smith, Tiani Vizcara, and Wendu Zhang. Thank you. For Wendu stands twice in 2 minutes. Yeah. And Shunyao Wang, the web chair, and making this hybrid event seamless. It's a very the way that it has run so far and without any major glitches. Thank you so much for this. And also the cyber facilities tour team. We can be a professional tour guides now. So thanks to everyone. Are you here? Anyone else here in this team? I think Joshua's here. Yeah. Dan is here. Yeah. And also session chairs. Thank you very much. And also Arya for Alija or Aliyah. What's your, sorry, didn't get your name.
Yeah, you can call me KB. My name is Kamashi Biswas. I'm working as a lecturer at Austin Catholic University.
Thank you. Yeah, thank you, KB, for for coming on, stepping out from Australian Catholic University to come and help, and many other session chairs like Mark Arting and Guangdong, Guo Wei, Lai Peng, and many more. Yeah, thank you. And also the sponsors from the CSS discipline. Thanks to Mark again, and also UQ Cyber School of EECS. And all the presenters, everyone worked very hard. Yeah, so thank you for that. And everyone online and offline, and I mean, we are in person as well. So, yeah, so see you next year. I think one more person I want to thank is Dan Kim. He didn't put his name inside here. And he's also one of the general chairs. So thanks, Dan, for putting everything together. So we have some, I think we have some water and light snacks. Is it here? It's there? Okay, yeah. So feel free to grab some food before you go and do the final networking. Hope to see you guys again. We'll be in touch again through another email to follow up for next year. Thank you.